Deep.
What's up, Charles?
Hey, you got your shirt on again.
I always have my shirt on.
Well, this means it's super special, so what's going on?
We are here kicking off a new series of videos today.
Sweet.
So we're going to spend the next couple of weeks or months sort of diving into different products. We'll start out with the ones that are in Azure and the ones that are especially close to us, as you're about to find out, that use Service Fabric in interesting ways or for interesting purposes.
Great.
And so with that, to kick things off, we've got Cesar with us here today.
Hi, I'm Cesar. I'm the engineering manager for the Azure messaging services. That will be Service Bus, Event Hubs, and Event Grid.
Nice.
Yeah, so we're going to be talking a little bit about, I think specifically on Event Hubs today. So hearing a little bit more about, how they use Service Fabric, why they use it, and what they've learned from it. Takeaways for us as the Service Fabric platform team, as they are technically our customer, as well as takeaways for you guys that might be doing things in similar ways or might be interested in solving similar challenges. Or perhaps even learning more about Event Hubs and seeing how you could use it.
Great.
So with that, let's get started with a little bit more about you. Could you tell us sort of a quick history on how you've ended up here?
Sure. So I have actually been, I guess now an Azure veteran. I started working on Azure when it was not yet called Azure. So I started in 2008.
Great.
I've been there for a while. It has been an awesome ride, actually. Developing new services, helping customers to actually be successful, keeping up with scale. So, and yeah, I hope to keep doing it for another 10 years.
Excellent.
That's awesome. And one of the things you mentioned earlier on is, you own the messaging sort of stack side of things. So that's Event Hubs, Event Grid, Service Bus. Could you give us a brief introduction to what those are?
Sure. So Service Bus is basically your traditional enterprise messaging service or server. So typical things that people actually use instead of Service are also IBM MQ series or TIBCO or RabbitMQ. So that's the kind of space. So you use it for traditional business processing logic, business processing messaging. It gives you high consistency features like transactions, deduplications. You can build sagas. Then you have Event Hubs.
What's a saga?
A saga is actually a fairly interesting thing, right? So imagine that you have actually a business process that needs to actually be processed by 2 or 3 different pipelines. And you have to actually guarantee that every pipeline actually consistently passes the message to the next piece. And you have to ensure that there are no duplicates. You have to ensure that actually they get transferred to the other side. So you can actually do that with basically Service Bus auto-forward capabilities as well as transaction capabilities.
Nice.
So we give you, for example, the capacity of saying, I'm processing this message, and by acknowledging this message, I'm also actually putting this new message that should go to that other queue. So with that capability of basically in the same transaction being able to say, complete this message and enqueue this message for that other process, then the forwarding to the other process actually is without duplicates. So you can actually ensure that this first pipeline definitely process this message, generate a new message as output, and then we guarantee that output eventually actually gets to the second saga. So
you can string together a bunch of these.
Yeah. In a sort of exactly once way for your full distributed pipeline. But that's Service Bus. It has a lot of cool features. That's why people that are actually doing business processing that mostly want to have their APIs the simplest way possible and just use a lot of rich functionality, they go through Service Bus. Obviously, those features come with some performance penalties, so you can do less transactions in an environment like that than if you are simply kind of like a distributed log, which is kind of like what Event Hubs is, right? So if we introduce Event Hubs, Event Hubs is basically a distributed partition log that actually supports multiple readers. So you can do pops up. In terms of the model, it's very, very similar to things like AWS Kinesis. It's very similar to Kafka, the Apache Kafka open source project. So you get a log, it's distributed, and so you can actually scale by partitions on that log. And then every reader can basically, or every consumer of the application then basically gets a lease on every partition, and that's how you ensure that it is that you're fully consuming the log. But yeah, Event Hubs is a partition log as a service that actually supports POPs of consumption. It is a multi-tenant service on Azure. So it is a multi-tenant service on Azure. We have we process on the order of like 2 trillion requests a day on
2
event
trillion
hubs.
a day.
Yeah, that's like 20 million.
Wow.
It is a ring zero service, so it's actually deployed on all Azure regions.
Right.
We are actually doing also work, and we are actually going to do a public preview by end of this year for actually bringing Azure Event Hubs also to Azure Stack, right?
Cool.
And one of the things that has actually been relatively easy to port Event Hubs to Azure Stack is actually that we are Service Fabric based, because our basically Event Hubs is pretty much a Service Fabric cluster with applications deployed on that Fabric cluster. And so what we did on Azure Stack is pretty much the same, right? We actually go and create a Service Fabric cluster for Stack, and then we deploy the Event Hubs apps, just like we do on Azure Public. So our transition has been relatively straightforward from Azure Public to Azure Stack.
Right.
Nice.
Other features other things that are that give you an idea of how Event Hubs work. Event Hubs is actually it's a multi-tenant service, so we typically deploy clusters of on the order of like 60 to 120 VMs, and then with those 120 VMs, we do actually service for on the order of like 3,000 to like 5,000 different customer applications. And for doing that, we actually use we can go more in details if you want on the
Yeah,
board.
we should.
But just as intro, we do that by basically creating every event hub customer ends up being a microservice in Service Fabric, and then we use load balancing the load balancing that Service Fabric has to actually be able to actually offer a good QoS quality of service for all the customers that are in that cluster.
So I'm going to make a plug here real quick. So for those of you that want to learn more a little bit about that load balancing that Cesar is talking about, that's the video we put out with Yang on the Cluster Resource Manager.
Right.
Because load balancing to us is balancing of resources in the cluster as opposed to of incoming traffic, which is another kind of load balancing that often is confusing. Yeah,
Absolutely.
Okay, so we're going to hear a little bit about Event Grid as well.
Sure. Yeah. And then, so Event Grid is basically a notification system that we actually built mostly to actually push Azure event-based programming. So it's actually fairly popular with the serverless application. And so you can think of it that Event Grid is actually supporting two scenarios. One is actually that Azure services, for example, like Azure Storage, are actually emitting all of the notifications that customers might be interested to actually program against. So, for example, in a storage account, every time that you go and create a new blob, that event about actually a blob getting created is basically getting routed to Event Grid. If you are interested on those events, right? We only route them if there is interest on it. But if there is interest on those events, then those events get routed to Event Grid. And then Event Grid can then basically push this notification to you to any handler that really supports webhooks, right? So you can actually have an Azure function, you can have a logic app, you can have your own service or your own server that actually just receives HTTP traffic. We can actually also push it actually to queues like storage queues or service bus queues or event hubs. But the idea is basically that you can think of it as you have actually all of the Azure services like storage, like compute for VMs itself, like SQL, like DocDB, I guess Cosmos DB now.
Cool name.
That basically are emitting events when basically new things are getting created, when new things are getting deleted, when users are actually taking actions. And then you can actually create subscriptions for these actions and receive them on basically something like an Azure function, and then just program basically based on that event when something happened. So that's actually the main usage of Event Grid. And so what we did for Event Grid was actually we had a model basically where we are able to actually set up multiple Service Fabric clusters per region, and then we actually use all the cool capabilities that Service Fabric has for actually like local replication, so that the service actually offers a high durability for the events, and it doesn't have to actually take any dependency on any other storage account or any other storage technology, but the VMs. So so we deploy, and we can actually do it in a fairly horizontal way for all the traffic that comes.
So you're using reliable collections?
Yes, we actually use reliable collections. We started with reliable collections. We are still actually deciding. What we do there is actually, it's really similar to a log. So we are actually discussing if we keep using reliable collections or we actually move it to the concurrent queue, or we even build actually our own log data structure for handling just that traffic. But yeah, at the moment it actually uses reliable collections.
Cool.
So one thing that I heard a lot actually was the use of the words consistency and reliability through that whole thing.
Yes.
And that's interesting because every time we have talked, so we've been talking in this other series that I was alluding to earlier to a bunch of the developers that have been around on the Service Fabric team for a while. And one thing that keeps coming up over and over again is like the core tenet or pillar of this platform is the word consistency. And sort of how it's impacted the way it's been designed and developed to run in all these weird, wonky scenarios and still survive and make sure that data that's in there is always consistent and understood across the entire environment. But anyway, with that, let's dig a little bit deeper into Event Hub specifically.
Sure.
So let's talk about the implementation a little bit. If you don't mind, feel free to sort of use the whiteboard, and we'd love to hear sort of how that works.
So let's talk about basically, I mentioned to you that basically event hubs are actually a multi-tenant service that it's implemented through what we call an event hub cluster, right?
Right.
So let's talk a little bit about first what is an event hub cluster, and then what are the different microservices that exist on this cluster. So an event hub cluster typically is 3 roles, right? So we have a gateway role that basically is the very traditional architecture of all the traffic that is load balance is coming here, right? So this is your front end role,
right?
And it's traffic that is going for event hub 1 or for event hub 2 or for event hub n, and so it doesn't know where to go. So it's a router, right? So it actually gets to this gateway. It also has actually a backend role that it's basically it has a backend role that is what we do for event hubs is we actually do volatile stateful.
Okay.
Yep. So for those familiar with Service Fabric, you probably know what it is. For those not that familiar, so volatile stateful is basically Service Fabric actually treats these services as stateful, so it tries to keep them on the same node, but the state is actually stored somewhere else, so it can actually move them around and kill them and revive them if needed. So traffic is coming to these gateways, and then basically it gets routed to the backend for depending for the event hubs. So let's talk a little bit more basically about our gateway and backend. So the gateway app itself, is actually a fairly simple stateless app, right? That runs on all those gateways, right? So it's a stateless app that runs with instances equal -1, so that it actually runs on all the nodes. And it's fairly simple, stateless app, it runs, it actually opens TCP ports, and then it starts receiving traffic, right? The main thing that the gateway app does is it actually basically verifies credentials, right? So it actually handles all the security to allow that the traffic is good. But the more interesting thing is also that it actually does the routing, right? For the traffic. So like for example, event hub 1 at this moment should go to machine 1, and event hub 2 at this moment should go to machine 35, right?
This is kind of similar to how SFRP works as well.
Yeah, in a sense. So, and I mean, I'm simplifying it here. I think it's the real logic here is not just event hub 1, because as I mentioned to you, event hubs is actually a partition log.
Right.
So it's more like event hub 1 partition 1 goes to that machine. Event hub 1 partition 3 goes to another machine. And this routing is interesting because the routing, the way we do it is these event hubs themselves, I'm going to explain a little bit later, are actually microservices, right? And so this routing is actually just using the naming client that Service Fabric itself actually has, right? So when it comes to actually figure it out at runtime, where is partition 1 for event hub 1 running, it actually just ends up being Fabric client calls for actually naming service to actually do a resolution for the given name for the given service and the given partition.
So these partitions actually map to the actual Service Fabric partition.
That's correct. Yes.
Okay.
So
Nice.
so the routing is basically just this naming client resolution, and then we do basically the routing for that.
Right.
I mean, other things that are not as specific to Service Fabric, but the gateway role actually ends up doing is the networking infrastructure basically between gateway and backend is actually not based on event hubs. So what we do is we actually establish a few set of tick pipes, for example, between gateway 1 and backend 1, right?
Okay.
And then on these tick pipes, right, then we really multiplex all the traffic for as many event hubs as is possible. So that also actually makes it such that when you think about connection density, the connections that the gateways have obviously is much bigger because they are actually multiplexing the traffic and actually reducing that work so that the backend actually ends up doing less work. Right?
Could you tell me a little bit more about what the thick pipes actually are?
I mean, it's just a simple concept that, for example, instead of the model of having for every one client connection that you actually get here, you're going to get a connection from gateway to backend, right?
Yeah.
Instead of these being one-to-one, we actually do n-to-1, right?
Oh, n-to-1, yeah.
And then we do multiplexing. We do it with the AMQP protocol that Event Hubs itself supports. But that the huge benefits of that is that you could have, for example, here millions of client connections that use memory and have to do SSL termination, versus here you actually have only a few ones. Right?
Yeah.
Smart.
You think?
Yeah, that's how we survive millions of per second.
Yeah.
Well, I mean, that makes sense, right?
Right.
You have to scale to that.
So now let's talk a little bit. Let's talk a little bit about this backend, right? Because this backend is really kind of what becomes a bit more interesting in Event Hubs.
Right.
So what we do in this backend is imagine that you have here many nodes, right? So they have, let's just say, for example, that there are 6 for now, right?
Sure.
And there is really one ring in Service Fabric. This gateway is also like the same ring, but for now, let's assume that this is the only ring, right? So what we do for basically every event hub that actually gets created, we actually go and create a microservice on Service Fabric, right?
Okay.
So every event hub that actually you have becomes a microservice, right? With n partitions, right?
And these are defined at the time of creation, actually, right? Because Event Hubs give you the option to say how many partitions do you want.
Correct.
I think I've seen it goes up to 15.
Right.
Okay.
Yeah. So I mean, the details are a little bit more contrived, but let's assume that there are n partitions.
Yeah.
Really, we actually create something that we wrongly call containers, right?
Okay.
We start using that.
Well, you used this word before somebody else.
We didn't trademark it, so now it's
too late. Yeah.
So what we do is literally, depending on how much throughput units you actually buy, then we actually have some formula for how many containers we actually create for you. Right?
Okay.
And then the actual event hub partitions then get allocated to a particular container at a time. Right?
So just real quickly though, I mean, your definition of container is still sort of an encapsulated blob of functionality.
Yeah.
Right? Big giant function or process.
Yeah.
Okay.
But I think that might get complex too fast. So let's assume.
Okay.
Let's assume partitions. Let's assume that we say you have n partitions, right?
Okay.
And then we go and create one Service Fabric partition for every event hub partition. Right?
Okay.
So,
but is that true, even not counting the container side of things, or no? Because
no,
you
it's
might
not true, right? Because we actually do. Depends on the throughput units.
Yeah.
Right?
Okay.
So, but yeah. So
then hold on. Sorry for a second, but in the case that this isn't the case, then how do you use naming to actually resolve the right partition?
Because we actually have a mapping of. For this event of this partition, what is the container?
And then the container
and then we resolve the container, right? So it's like 2 lookups.
Okay, makes sense. All right.
So, but anyway, so let's assume that you're actually dealing with an event hub that requires 20 TUs, right? In which case we actually go and create 4 containers, right?
Sure.
So we go and create a microservice with 4 partitions, right? And then those 4 partitions are basically like any partition in Service Fabric, right? So like it will go, partition 1 will be here, partition 2 will be here, partition 3 will be here, partition 4 will be here, right? And then Service Fabric actually gives us all the nice guarantees, for example, that, hey, at any given time, you can actually rely that only one primary and exactly one primary,
Yeah.
right? Exactly one primary is the owner for that partition, right? So there is exactly one primary. You can also count basically that your partitions will actually be distributed among fault domains and
That gives you some resilience.
fault domains and upgrade domains as good as possible, right? So that will basically give you also resiliency that whenever you are actually doing upgrades, whenever Azure itself is doing OS upgrades, then only certain partitions go down and not all of them at the same time, right? So we use that, and yeah, you were mentioning actually if these services are created basically on demand, and yes, they are created on demand. So basically, every time that a customer comes and provisions a new namespace on event hubs, then we go and basically create this microservice on demand, on the fly.
So that effectively means there's some kind of a service manager service that runs somewhere on the same cluster, right? That's interesting.
Yeah, which is actually the last role that we have, right? So we have an admin role, which is actually the control plane of this event hub cluster, right? And so anything that has to do with control operations, like create a new namespace, delete a new namespace, create an event hub, delete an event hub, increase the TUs for that event hub, because you might actually increase it enough that we actually have to deprovision this and go to 8 containers or 12 containers.
Sure.
So all of that is actually done here, right?
Okay.
And it's interesting, actually, all of this is actually done in this admin role. And this admin role is also interesting because it's actually a workflow engine. And the workflow engine is basically built on top of reliable collections.
Okay.
And something actually called distributed task framework.
Okay.
It's actually an open source project in GitHub. And it actually allows you to create kind of like persistent C# in a relatively easy way. And so we build a provider for this guy using reliable collections. And so we can actually build workflow operations in this admin in a relatively easy way.
That's actually something I didn't know about that, and I feel like people might actually should use that.
Yeah.
They'll probably find it useful.
Yeah.
Do you know where that lives on GitHub?
I can find it for you. I don't remember.
We'll put the link in the description.
But the name is Distributed Task Framework.
Cool.
So
Nice.
And so yeah, it's actually a workflow engine. So we get a call, we start a workflow instance in that case, and then that workflow instance has to go through a state machine until it is completed, right? Because all of these operations could actually take a long time, right? Or they could actually fail and they need to be retried until it gets to a given state. For example, the workflow for going from like 20 TUs to 40 TUs actually has to delete the service fabric service, recreate it, remap the partitions. So it's a long running thing. And so long running as in like 20-30 seconds.
This is interesting because there used to be a time, and when you guys built this, repartitioning was not something you could do in Service Fabric. You effectively had to rebuild. But I don't know if you've seen.
That's what we do here, right?
But yeah, but recently we're introducing, or we're at least working on new partitioning schemas while your service is actually running. Yeah. So that might help a little bit.
Yep.
Yeah. When it happens.
So other things, yeah. So because we use Service Fabric and we have this partition service. So yeah, you get the benefits of ensuring that the primary is actually
in one place.
The primary of a given partition is exactly one. The placement is actually fault and upgrade domain aware, so that actually helps with your availability. And then finally, we also actually use load balancing, right? And so load balancing is actually a very critical problem for us to solve on event hubs, because remember what we are doing here is, as I say, we have a cluster that is basically on the order of 50 to 100 VMs, right?
Okay. Is this one per region basically, or?
No, we actually create many of these per region.
Okay,
right? So
just as many as you need.
Yeah, it's kind of like our scale unit. So what we do is, we start basically with clusters that are around 50 VMs. Then we pack them with like 2,000, 3,000 different namespaces. And then we seal those clusters. Then we open new ones. And then as the traffic actually grows on the clusters, because it typically grows, then we actually auto-scale that cluster. Right?
Interesting.
So we actually add more resources into it.
So how do you do that? what do you do it based on? What's the unit for auto scaling?
So the units are typically resource based. So the units are typically like the CPU that actually is
so these are
being used by the clusters, the network traffic that is happening on the machines. I mean, it's not uncommon for our clusters to typically be running at like 40 to 60% CPU, for example.
Okay.
So like that problem of like low CPU usage, we don't really have it.
Yeah, okay. And
the other,
I guess out of curiosity, at what stage do you decide you need a new cluster or you need a new set of VMs? 70%, 80%?
Those actually are still for us like some set of rules. So as I say, like what we try to do is we try to limit basically clusters to be on the order of like 3,000 to 5,000 namespaces.
Okay.
So every time we get to 3,000, 5,000, then we just build new stamps. And we seal the existing clusters so that they don't get new namespaces.
What happens if those namespaces get deleted?
Yeah, so if they get deleted, then we reopen them and then we get new namespaces. But think of it as kind of like a bucket algorithm.
Well, that means that there's some manager of clusters somewhere that's running as well.
But I'm not gonna go into that.
Okay.
But there is a manager of clusters and all of that.
Yeah, interesting.
So yeah, typically an Azure region, in the busy Azure regions, we will have basically on the order of like 20 to 30 of these clusters now, right? And the number of clusters has been typically doubling per region about every year, right?
Congratulations.
So it keeps going.
That's huge.
That's great.
Yeah. So you don't get to 2 trillion requests a day unless you're running very fast, right? But going back to load balancing, right? So what does it mean exactly for us to be load balancing, right? So the interesting part is that, remember, I'm saying that these are 50 to 100 VMs. Then we end up having basically something on the order of like 3,000 to 5,000 effectively SF services, right? On these clusters. Every service has typically 4 partitions, 4 service fabric partitions. So we're talking that these clusters typically end up having then between 12,000 to 20,000 SF partitions, right? Mm-hmm. Now, because of these numbers, we cannot really, so Service Fabric actually supports that your services run on shared process or exclusive process. So if you're going to have these VMs and that many partitions, then exclusive process is really not an option for us, right? So we actually run with shared processes, right? And so that makes it also more interesting that, well, if we are doing shared processes, then how can we really do load balancing, right? Because we cannot really use simple metrics like CPU usage or like memory, because it's actually a shared process.
You don't know which one of it is heating up, how to kill.
Yep. Yeah. I mean, you will know that, hey, like the shared process is using 80% CPU, but that shared process is really hosting 500 different service partitions, right? Mm-hmm. So our load balancing is actually we actually use custom metrics for that load balancing. So we keep track of basically things like incoming events per partition. We keep track of outgoing events per partition. We also keep track of, we do both count and we also do bandwidth, right? So we do, what is the incoming bytes that a given partition is having, and what is the outgoing bytes that a given partition is having, right? And so with this matrix, it's actually that we then configure the Service Fabric load balancing so that these matrix are basically about even for the load balancer, right? So, and then what load balancing does is we report these metrics, I believe, about every 5 minutes, and then load balancing is kicking in every 10, and then rearranging the cluster to actually be as evenly balanced as possible. So that's what we do for load balancing.
It's kind of very interesting. Yeah. Why 5 minutes and 10 minutes? Because we see a lot of people choosing between faster reconfigurations because they want to be more optimized, or slower because of disturbance and availability, for example. So
so for us, it's also that it is also actually based on that disturbance, because some of the end to end, what we see basically is that even though the impact, for example, of this partition moving from this node to this node is relatively minimum, you do have to actually see that sometimes a full circuit actually has to get reestablished.
Right.
And so if you're doing that really constantly, then you actually are constantly like terminating your connections, and then your clients are actually having to reconnect. So tuning actually like that load balancing, or like which matrix do you use, how often do you balance, what are even the thresholds of like when do you decide, oh, is this too balanced or is this okay, right? So like all of those is actually like really the hard part of load balancing, right? And so that's part of things that at least what I have found with load balancing in Service Fabric is, but I think that's just any load balancing algorithm is the actual tuning for how do you actually get your workload to actually perform in a consistent way. It's the hard part.
So we get a lot of questions on resource governance and setting, scaling, policies and metrics correctly. Oftentimes our advice is generally you just have to test, get data, and figure out what works for you. But as somebody who's gone through that, what would be maybe more specific advice that you could give for somebody who's trying to build a highly scalable or high throughput system that needs the highest amount of optimization in balancing across a cluster? What would be the how would you point somebody in the right direction to come up with this matrix for themselves?
That's a very hard question. I definitely think that, your guidance actually for you as a user having to actually test and see what works it's very real. It's very realistic too. But at the same time, I do think that basically you do have to actually step back and basically see what are the different models that you can actually have for load balancing, right?
Sure.
So for example, in the case, and for example, like in our case with event hubs, we went with shared process because we really have this scale, right? And the requirements that we actually need on event hubs are actually such that the price that we actually have to meet, the workload that we use on event hubs is also relatively straightforward in that, hey, things are coming in, we do almost no work except saving the data. We need to push the data out when you come for it, but again, we do almost no work. So it's very, the usage that we have is very transparent, right? Like events come in, events go out, and it's very transparent, the extra work that we do. Where if you were writing actually something that is higher level, something that actually has to do business logic, then more likely your CPU usage on that higher business layer may actually be harder, right? Or the amount of memory that you consume in those business transactions might also be harder to predict. So in those cases, for example, you might simply go to a simple model where you say, well, I'm going to assume ahead of time that my service is actually going to need one CPU or it's going to need 2 gigabytes of memory. And so you do that load balancing more actually on a resource reservation basis,
right,
versus like highly dynamic like what we are doing here, right? And in fact, we use both, in my team, we actually use both models, right? So in the load balancing for event hooks, for example, is based on really completely at runtime, totally dynamic, based on just events in, events out, versus on service bus, because of all those high consistency features and sophisticated features, we have to build indexes, we have to use memory, we have to use CPU sometimes. So the model there actually doesn't really work that well for us to actually be trying to balance every single event that comes in. So in service bus, what we did is we went to a much simpler model where we say, when you create a service bus namespace, you actually have to tell me how much resources do you want me to use. And so that's actually an exclusive process, and then we just actually then dynamically load balance the reservation that you did.
Sweet.
But not the dynamic one.
Makes sense.
But I think load balancing, a lot of it really depends on what are the constraints that you're trying to satisfy, what is the mental model that really will work for you, and then after you are convinced that the mental model will work, then you have to do the tuning to really make sure that works.
Like what was your experience like expressing to Service Fabric, this is how I would like you to conduct dynamic load balancing?
Once you define your model, it's relatively straightforward, right? So you will go to your cluster manifest in Service Fabric, and then basically define what is your node capacity for those metrics for every node in Service Fabric.
Right.
So you will go and say, a service here, for example, is able to handle 50,000 or 100,000 events per second for in or for out, right? Then you define the capacity for the node for all of the metrics. Then you define basically the thresholds where you want to actually kick load balancing and basically how hard you want to load balance. So that's kind of like the cluster definition. I believe you also have to define an initial or default load that the system actually has to assume for a service that is just getting created. Right?
Okay.
So you have to define that, and then finally at runtime, your microservices actually have to be reporting this load periodically, right? And that's actually just a Service Fabric API call. Right? So every minute, every 5 minutes, then you actually will report how much load is this microservice observing, how much load is this microservice observing, and then after that, then Service Fabric does magic, right? And the main thing is you do have to be aware that your partitions will move every time that the cluster is unbalanced. Right. So the other thing that is also a lot of interesting work is every time that a partition moves, it's a reconfiguration, right? And so you have to ensure that, and again, because Service Fabric is actually a highly consistent system, you have to ensure that actually like your reconfigurations never get stuck, right? Yeah. So if Service Fabric tells you close a replica, you have to close the replica. If Service Fabric tells you open the replica, you should open the replica. Because if it gets stuck on close or on open, then it's going to be there until something gets it out.
Yes, and then we have an ICM incident.
Yeah, correct. Well, this is why we always talk about making sure you're doing the cancellation token handling correctly, because it's super important to make sure that your Control C is taken care of. Because I mean, like you're pointing out here, these are just processes, and we're like, okay, this is a process. It weighs so much. It has certain properties. You told us this is how much we should care about it, and when it gets too big, we do stuff. Yeah. But beyond that, we're still operating as a black box at the end of the day, right? Like, sure, we have some hooks in your code. Sure, we have made you use reliable collection, or you may have like used some aspects of Service Fabric inside your application. But the way we treat that is still, at its very fundamental, like a unit that is a black box to us. So you've got to educate the cluster.
And to be fair,
I like that. Educate the cluster.
And to be fair, for example, there is no good way to how to handle it, right? Because, for example, think in this case, I mean, you have a shared process. This shared process is probably having 500 to 800 partitions, right? The load balancer has decided that, I'm going to take 10 partitions, right, and move them from machine 1 to machine 3, right? And one of these partitions actually happens to throw a feed, right? And now it's not closing, right? So you would say, well, why doesn't Fabric kill it? Well, if it actually kills the process, it's going to kill these 800 partitions, which is going to be worse, right? So you actually have to just do all the hard work to make sure that, when you get a close, you close, and you close as quickly as possible.
Cool. Okay. So I want to take a step way back and sort of bring you to when you were architecting event hubs, like sort of back in the day, as many years ago as it was. Walk us through sort of what your options were at the time, sort of how you made the decision of it made sense to run on Service Fabric, or it didn't. So sort of people can try to empathize with the decisions, and for those that are in similar situations today, it may not be in the messaging world, but we do have a bunch of customers, for example, that run in finance that think a lot about high throughput, low latency communication across multiple machines. What are the decisions, or what are the things that they should be thinking about when evaluating different options that they have?
Sure. So I think to answer that question, one of the key pieces, for example, is I haven't actually touched at all why something like exactly once is actually important, very important for event hubs, right? And so after we do that, then I think
that makes sense.
This is a key requirement for us, and so we need a framework to solve partition ownership, right? And then I can tell you the history of how and why and how speaking on Service Fabric has been a good bet. So what we do with these partitions basically is we do require basically for this to be exactly once, because these partitions are basically in charge of buffering all the traffic and doing actually heavy caching for those partitions, right? So what happens is, imagine that you have again one event hub with 4 partitions, right? But each partition is actually getting potentially thousands of requests per second. So we don't really, and then this that traffic that is coming for like send messages eventually translate to IOPS, right? And so we don't want actually every customer transaction translated to one IOP, right? Because then if you're doing millions of transactions per second for your customer and you need millions of IOPS, well, that's going to be challenging, right? So instead these partitions take full advantage of actually the guarantee that, this partition, there is exactly one in the system, right? And so all the gateway traffic is going to basically collect it there. And then this partition is then just actually buffering the traffic and then reducing the number of IOPS as much as possible to the store system, right? And if we didn't have that, then basically we will not be able to actually give you guarantee order for you, right? We will not be able to actually reduce actually the number of IOPS in a significant way from what the customer is really requesting, right? Similarly for reads, on reads basically on writes, to summarize, on writes we actually do a heavy reduction of IOPS, right? Because we can actually count that there is a single master for a given partition. And then for reads, again, because we can actually guarantee that it is one, we know that, for example, the writes and the reads are actually served by the same guy. So we can do heavy caching of the data because the same guy that is writing it is probably going to receive the read for it, right? So this, for example, like you will be surprised, right? Like a lot of customers actually use event hubs to actually process data as quickly as possible, sometimes in the same subsecond, right? So our ratio, for example, from reads versus writes versus reads is 300 to 1. So we mostly never read the store because most people are actually reading the data as quickly as they can. And so a write comes in, we ensure that it's actually stored so that if we restart, it's there. But the actual reads are just satisfied from in-memory. And we're able to do that because it's actually an exactly one, we have the guarantee that there is exactly one master for that primary, right?
So this actually answers another question I had, which is, now I know why you don't read from secondaries as well.
Yes.
Because you're caching in memory and you want to be able to do the same.
And we have a ratio of 300 to 1 for writes versus reads.
Yes.
So, all right.
Very interesting.
So now going back to what we solve with Service Fabric. Well, I mean, if you look at it, right, regardless of which clustering technology and partition management technology we will have picked, the requirements are that we will have to have basically on the order of about 1,000 different partitions per VM, right? We will need to guarantee that you actually can elect, you have leadership election cleanly and reliable and available and as fast as possible, right? Then you also need to actually solve load balancing, right? So, and then typically your leadership election and your load balancing cannot be split apart, right? Like they are kind of one and the same, right? So, so we started writing this service probably back in 2012, right? So I think back in 2012, I don't even know what else we could have used, right?
That's so true. That is true.
We considered actually basically, well, we could actually build like a Paxos assemble in this admin, and then this guy is going to be the controller. Yeah, we could have done that. Right? Even if you use, for example, some of the open source technology, right? Like I see that a lot of projects actually use Zookeeper, and then they actually try to use the directory that it gives as well as the notifications to try to build that basically with business logic, but it's not actually as easily expressible as basically what Service Fabric gives you already with partitions, with a very simple model to say, well, you are a partition, you are supposed to reconfigure, you close, you open, and then the placement aware constraints. So yeah, I mean, it's for what we do it's actually exactly what we need and has worked really well.
And that's awesome. And you got to spend the bulk of your IQ and time on your problem.
Correct.
On your problems.
Yeah, we just worry about writing messages and sending messages.
Yeah, because underneath, I mean, this is where like when people ask like, hey, what is Service Fabric exactly? And then we answer like, well, Service Fabric is a distributed systems infrastructure.
Yeah.
Service Fabric is a distributed systems platform. It's because it's that, where you don't have to worry about the complexity algorithmically to solve like these hard problems. It's done for you.
Correct.
So in 2012, you met Gopal.
Actually, I didn't met Gopal. We started using Service Fabric in 2012, and then I met Gopal 2 years after that.
Oh, okay. Right on.
Interesting. Right on.
So I also kind of want to hear a little bit more about how Event Hubs has evolved since 2012.
Sure.
So how has your thinking changed about it? How are you thinking about it now? And this is a very exciting time for Microsoft because Ignite is a big time for Microsoft in general. Would love to hear sort of where you're headed, and if there's any interesting things you'd like to get out there, please feel free to.
Sure. I mean, in terms of Event Hubs, It's actually, as I say, it's a fairly mature services. We process around 2 trillion transactions a day.
Every time you say that, I laugh because
we deploy it on all.
If I had a penny for everyone.
yeah. Actually, the worst part is actually when you write it, because you have to write 2 and then 12 zeros after that.
Nice.
So if you don't put commas, you lose the number of zeros. So anyway, but yeah. So coming back to what we are doing with Event Hubs is. We are actually adding a lot of features that actually will make Event Hubs actually integrate even better in the Azure ecosystem. So for example, we just did the preview for availability zones so that you get even more availability whenever there is power outages and things like that on Azure regions. Maybe you should cut that.
It's okay.
But
it's a reality.
Power outages happen.
Definitely it will be even more available. Then we're actually adding BNet support so that you can actually constrain traffic for Event Hubs or into Event Hubs to actually only be accepted from a given BNet. So we're actually adding BNet support through service endpoints.
Cool.
Then we're actually doing support for RBAC and MSI based on AAD, so that you can actually have a full characteristics of access control policies that you can actually constrain it much more. Then and then the final one, the one that we're actually super proud of, is we are actually we have in preview since build Kafka protocol head. So Kafka is a fairly popular open source system for scenarios that are very similar to Event Hubs. And so we actually built a protocol head that actually looks exactly like Kafka. And so you can actually take any Kafka tool or any Kafka application that you are actually running and then just pointing to an Event Hub namespace and it will just magically work, right?
Awesome.
So, but you don't have to manage a cluster, right? So you create you go to Azure, you create an Event Hub namespace.
Manage Kafka.
Yep, and you give it to your application, and you're
taking care.
Right?
And
and you can start, I guess, the minimum price for an Event Hub namespace is $25. So I guess you could have your managed Kafka cluster for $25.
Right, which is a lot cheaper than having to manage your own.
Yeah.
Both from time and money perspective. Yeah, exactly. And so it seems like there's both like innovation on your infrastructure side of things, as well as like the experience, the user interface, and the platform that you're providing. For the infrastructure thing, so this AZ sort of, how are you pulling that off? Are you having clusters that are forced to span that, or are you doing management now using that admin or the thing that we talked about, which is the management of clusters?
So good point. That was actually, so I mentioned that actually from an infrastructure point, the bet on Service Fabric has actually been great, for example, for availability zones, because we make this ring actually span across availability zones. Okay. Right? And so we really didn't have to do much except that we had to actually build the cluster in a different way, right? And so now
empty mapping and all that.
Yeah, so we actually build a cluster that spans across the 3 zones. And then again, Service Fabric is also aware of that, of those different availability zones, and so your replicas will be actually AZ aware. And similar to Stack, right? So in the Stack also was like, hey, we are already a Service Fabric app, so we just need to deploy to a Service Fabric cluster.
Yeah, because that runs as well. One second to last final question for you, and you're going to hate me for this, but I have to do it. Can you please explain the relationship between containers? It's killing me. Just briefly.
Actually, it's very simple. Right?
Okay.
So, I mean, it's long but simple. Right?
Yeah.
So,
what's the short version?
Well, since you want to know all the details, I'm going to tell you all the details. Right? It's very simple. A container is a container capacity for us is about like 5 TUs, right?
Okay.
A TU is actually a throughput unit, and so it actually consists of 1,000 events in, or a megabyte per second.
Okay.
1,000 events per second or megabytes per second, and then twice the output of that. So 2,000 events out or 2 megabytes per second. So think of it, a container is 5 times that, right? So when a user comes and creates an namespace between 1 and 20, then we always go and create 4 containers, right? If a user comes and says, no, I want 40, right? Then we go and create 8 containers.
Sure.
Right? If a user says, I want 60, well, then we go and create 12 containers, right? So for every 20 TUs, we create 4 more containers, right? That's how many containers we create, right? And then when it comes to partitions, we just basically run robin.
Okay.
So if you, regardless of how many containers you have because of your TUs, if you come and create an event hub with like 30 partitions, we will go and round robin across the containers.
Cool.
And that's the mapping.
Thank you so much for your time.
Yes.
We appreciate it. We might have to bring you back to discuss event grid and service bus at some point.
Yeah.
This is super informative. I learned a bunch. So
Absolutely.
really appreciate it.
All right.
Yeah,
Really
thanks.
nice
Thank
job.
you. Yeah.
Cool. So we'll be back.
We have some good stuff coming up.
Yeah, we'll be exploring a bunch of services, some of the popular ones, Cosmos DB, functions at some point, a couple of the others. So looking forward to it. Stick with us. Lots of content coming on the way. And thanks, Charles, once again for
Thank
being
you.
here with us.
All right.
Thank you, guys.
Thank you. We'll see you again.
Yeah. Thank you.